Welcome to my presentation 2, Definition and Applications of Number Theory for Math 4035, Theory of Numbers at Mayfield State University. I'm recording this presentation in spring 2023. The famous mathematician Carl Gauss once praised that mathematics is the queen of the sciences and number theory is the queen of mathematics. So, this quote actually made me curious about why number theory has such a high status in mathematics. Here I am. In my presentation, I want to briefly discuss the definition of number theory. And also in my research, I found 3 applications of number theory. The first one is cryptography. The second one, I want to speak from my own experience as a secondary math teacher. So I want to talk about a few applications in my own classroom. And the third one is Cole Prize, which is dedicated to achievement in number theory. Here are some key words in defining number theory. It is a branch of mathematics concerned with properties of the positive integers. It is also called higher arithmetic. It is fascinating to both mathematicians and amateurs, and it can be found from prehistory to modern minds. Some people say that number theory is pure mathematics. I put a question mark here because in this presentation, we will see some modern applications which might make people question whether or not it's still pure mathematics. And I found it very interesting that number theory is called the queen of mathematics for its purity and lack of practical applications. Basically, I would say this is a field that speaks to pure and abstract beauty, but also we see some fascinating and brilliant modern applications. I'm a big fan of word clouds as they inspire readers to make connections among relevant fields or concepts. So here is a word cloud of number theory. Are you finding any surprises here? Moving forward, I want to discuss 3 current applications of number theory. The first one is cryptography, which means a means to ensure the integrity and privacy of information in communication. A classic example is Enigma, which was used by the Nazi during World War II. Later, Alan Turing, among other cryptographers and mathematicians, participated in code breaking, and this, among other factors, led to the end of World War II. The foundation of cryptography is that there are infinitely many prime numbers. As numbers grow bigger, it might not be difficult to find composite numbers. However, it can be challenging to find prime numbers and also prime factorized huge composite numbers. Thanks to modern computers, coding and decoding in cryptography have been further improved. So here is a picture of Enigma. Okay, here is another word cloud. This time is cryptography. Again, are you surprised by any of the keywords here? Here is the second application, which speaks to my own passion and my day job. I enjoy engaging my middle schoolers with numbers before they move on to more abstract thinking in algebra. And this is an example that I use in my grade 6 classroom. This is the sieve of Eratosthenes. And we actually use this one to find patterns among prime numbers. And also we use this to see patterns among multiples of 2, multiples of 3, multiples of 6, 8, 10, and so on and so forth. The color coding really speaks to middle schoolers as they are digesting prime and composite numbers factors and multiples at the same time, it can be confusing to them, but the colors help them to think and find patterns more easily. And this is an example for my grade A students. As students are learning linear equations and modeling with graphing software, I give them this real life application to think through. So this is one of the problems that we're working on. Purchasing a sheep for a family cost 60 Australian dollar and a beehive cost $42. If a family decided to purchase 15 items at a total cost of 720 Australian dollars, how many sheep and beehives are purchased? And then the second half of the problem. The family decide to sell some of the sheep and some of the beehives in a year. Each sheep is sold at 150 Australian dollars and each beehive is sold as 90 Australian dollars. So how many sheep and beehives should the family sell at minimum to earn $60 in return? So here's how I would solve this problem. So first of all, my students, they're familiar with defining the variables, and they're familiar with writing system of linear equations, and they're taught three different methods at this moment, the substitution, elimination, and also graphing solutions to find the values of variables. So these are the solutions. And then the third part, that's the fun part, because number one, the family have purchased 5 sheep and 10 beehives, which means that, well, when they consider the amount of sold sheep or beehives, they need to consider the upper limit. And also they need to consider that because they're thinking about sheep and beehives, the solutions need to be positive integers. And they haven't really learned about Diel-Phantom equations, so I actually taught them to use a table method to find potential combinations of the two variables. And here we go. So then from this table, you can see that they actually have two possible solution sets. And then at the end, they need to write the conclusion. But also I tell them that they need to find the at minimum. So they would actually choose the screen one as the best solution. The third application I want to discuss here is Cole Prize. It was founded in honor of Professor Frank Nelson Cole upon his retirement from American Mathematical Society, AMS. And the prize is given to people who make contributions in number theory and algebra. And the prize is 5,000 US dollars, and it's given out every 3 years. The most recent one, the 2023 one, is awarded to Kaisa Potomaki, James Newton, Maxim Ratzel, and so on and so forth for their paper titled Multiplicative Functions in Short Intervals. So I don't feel like this Cole Prize application is really that practical, but I do find that this thought of encouraging young scholars to grow and providing the word very noble. So here comes to the end of my presentation. These are my references in my research. Thank you for listening. Until next time. Bye-bye.